Let's look deeper into the logic gate. Here is an example of 3 NAND gates put together. I want you to work it out by figuring out all the different cases. Apparently, you can see something special for this is the input of these NAND gates. These two are wired up together. That actually means if A is 1, then going inside this is also 1 and this is also 1. And yeah, this is the representation when they are both 1. Imagine this is the voltage, then the voltage is high for both of these. Then it has to be, I mean, if this is, let's say, low, then this has to be low as well because they are on the same potential, on the same wire, so same potential. So that actually means you also have 4 cases, 0, 0, 0, 1, 1, 0, and 1, 1. Pause the video now. I want you to work out the rest. Basically, what I want to know is F. And for assistant, you may want to set up 2 intermediate variable called C and D on your truth table as well. Try to work out all the answers according to what you learned in the previous video, and then get back to the answer after you finish it. Pause the video now. Okay, let's try to work it out together. So we have 0, 0. Well, actually, let's look at A and C first because B and D are more like independent to A and C. So if A is 0, then imagine it's 0, 0. 0 and 0 is 0, but this is a NAND gate, so you have to reverse it. So 0, 0 is 0, reverse it to be 1, so 1 here. And in a case where we have 1 and 1, so for example, this is 1 and 1. When A is 1, then these two are both 1. 1 and 1 is 1. Reverse it to be 0. So it will become 0 for this. So that means this 1 becomes 0 for C. And basically, using this idea, you can work out all the possibilities. So for same for B and D actually. So if B is 0, that means this is 0, 0, and then it becomes 0. Reverse it to be 1, so D will be 1. And that actually means what you have to do is to reverse all of them. So 1 becomes 0, 0 becomes 1, 1 becomes 0. Next thing that you want to do is by looking at locally here between C and D, and then you can work out F. So for 1 and 1, it will give you 1. And then again, this is a NAND gate, so reverse it to be 0. 1 and 0 is 0. Reverse it to be 1. 0 and 1, same for the previous case, is 0. Reverse it to be 1. 0 and 0 is 0. Reverse it to be 1. And the most interesting thing is by making up this combination, like this whole structure, and then if you look at your input, this is your input, the most primary input, and this is the really final result. You will find out one interesting thing is, if you look at these gates, 0, 0, 0, 1, 1, 0, 1, 1, and you actually have this result. Take a look of this. Do you actually know that this is one of the gates that you had in the previous video? 0, 0 give 0, 0, 1 give 1, 1, 0 give 1, 1, 1 give 1. That actually is OR gate. And the best part of this is, think about that, just now in the circuit, you only use 3 NAND gates. And by using a NAND gate, you can actually get the OR gate. At the same time, if you pay attention enough, NAND gate just now, when we just simply wire up both of these A, and then you get the result, say C, this is in itself is actually is a NOT gate over here. So the best part of this is, for a manufacturer, they only have to build NAND gates, and then they can actually make all kind of gates that they want. Here, I'll put the link in the description. It's a very interesting game where you can build NAND gates, building all other gates using only the NAND gates. I'll show you maybe 1 or 2, and then you can try to play for the rest of them. Here's a game. I'll put the link in the description, and it's not mandatory for you to learn, but I just think this is truly amazing game. You can try to work and play around with it. So here we have got a lot of NAND gate. You can try to drag it out, And what you have to do is apparently this is the target you want to build, and you can actually see this is a NOT gate because it reverses the result. Gray means like false and green like true. So what you have to do is simply drag this. This is how you can make the gate, and then you can try to test it. If you test all of this, then that actually means you build a NOT gate. So after you build it, you can actually use it in the next level, because again, remember, everything that you build is based on NAND gate. Let's take a look at the next one. This is what? This is AND gate, I think, right? AND gate. So let's see. I think we could do this maybe, and then reverse one of these, because just now we built, let's see, can we, oh wait, we can't do this. Can we do, no, we can't do this. Can we clear, maybe like this? Oh no, I think it's like something like this, because apparently it's not the same gate that we had in the exercise. Let's try. Oh wait, it failed. One NAND and one NOT. Oh no, clear. So you can see it's not actually that easy. Is it just this? No, is it? Oh yeah, this is how you can build AND gates. Okay, and apparently this is the same as the question that we had. So 3 NAND gates, and then these are all wired up, and then like this, I think. Okay, and this is how you build all gates. So for the next one, you can also try yourself by using the gates that you had. You may want to click the hints if you want, and again, it's just a game. All right, if you like to play it, then try to play more. I think there are more than 10 level, I think, so you can try to play around with it.